Assalamu alaikum wa rahmatullah. So, in this particular discussion, let me just go and discuss something regarding the physics of lens. Okay, and typically I will just look for here the problem which belongs to the physics of lens. What the problem is basically all about. Let me just first of all look the content in the problem. अगर प्रॉब्लम हमसे ये कहती है सपोज वी आर गिवन अ लेंस ओके डबल कन्वेक्स लेंस हमारे पास कोई डबल कन्वेक्स लेंस है ओके वी जस्ट कट दिस लेंस बाय मींस ऑफ द प्लेन हम इस लेंस को कट कर रहे हैं किससे एक प्लेन से but that particular plane is perpendicular to the what we call as the principal axis of the lens okay this is sometimes we call also the optic axis okay no issues there are but we take here the plane such a plane is perpendicular to the principal axis here and the plane is used to cut the given lens here okay into the two equal parts but it's also given in a question the original lens has the power of original lens has means the lens that without any cutting pieces here we have the full lens here its power is given as 4D units 4 diopter units okay and we just cut this lens we are just cutting this lens in a way that we take some plane that a plane is perpendicular to the optic axis here okay and we are getting the two pieces of lens but the two pieces we get they are equal through all respects okay means that we just cut this lens into two equal parts by means of the plane okay after cutting this lens we got the two sub lenses here like this way this is my one piece of a given lens and this is its another piece okay I need to find here the power of cut lens okay I cut a given lens into two equal parts suppose this is my part first here this is my part second here I need to take here the one piece of lens here I need to calculate its power okay it is something that we need to understand here very bravely okay so how we can just look for the problem of this type look when we talk about the lenses okay so in order to manufacture any lens we use the formula that's some lens maker's formula what that formula is basically that's inverse of f it's a relative refractive index okay minus 1 times 1 half of r1 by r1 minus 1 by r2 this is known as the lens maker's formula while r1 is the radius of one spherical part here okay and r2 is the radius of another curved part here okay and this is what we call as the refractive index of a given material of lens okay refractive index you know it's a measure of optical density of a given material and all that okay so we need to calculate here the power as if the power of original lens is given as a 4D units okay how we can just look for the problem of this type look it's not a big deal here to find the answer of this question because I can find it at the first place like there are the two symmetrical pieces of this original lens okay obviously my power will be here the 2D for this and 2D for this it's not a big deal here to find the answer but logically if we think on this question we can find here this answer okay but if I will use this formula I will get the answer here more firmly in a way then after it should not look too dangerous for me to get the answer because if I will use this equation I will get the answer here that I told you its answer is here the 2D okay units means the power of a cut off lens is here the 2D units it doesn't matter whether to take this or this it really doesn't matter because moment you take the second piece of the lens here we need to take care of only about the sign conventions okay and rest of story will be as usual for both the piece okay but the question asks us to calculate the lens of the power of a cut of lens okay means whether you take this cut choice is completely open whether you take cut first or cut second of a lens choice is completely open here but only thing you need to care about you need to look for how exactly you can use the sign convention rules and all that after all using this formula okay look how I can use this equation here as if the power is given as, for this full lens, that's 4D units. This is how we define the power, in case that it's defined as the inverse of the focal length of a given lens. That's given as 4D for a given original lens, and then after we just use the plane and we'll getting the two pieces here, okay? And we need to calculate here the power of a cut lens, okay? Whether you need to take this or this, choice is completely open, but for the sake of argument I will just take here this part, okay? Because in order to take this part, it becomes easy for me to use the sign convention rules and all that. Again, I will just make the use of here moment. I will take here this part in consideration, okay? Okay, for that this will be my R1 here, okay? Okay, and this will be the this will be, I need to take the radius of this plane part here, but it's known to me the radius of the plane part of the refracting surface, it is infinite, okay? No issues there are, but what I need to do here, I need to just look for this equation first of all for this original lens, so that I will get here something very important. Look, when we talk about this power, it is going to be 1 over F, that's mu minus 1, okay? 1 over R1, that I take as R, because it is, we are just cutting this lens into two equal parts, means that whatever the radius of curvature of this curved part, it will be same as that of this part, okay? If I will just take the radius of curvature of this part as R, okay, it will be minus of, yes, the radius of curvature, it will be R for another part of this lens. It is by means of the symmetrical argument and all that, okay? Because it's a question that tells us about, we take here double symmetrical convex lens, okay? So here it will be, yes, when I take the radius of curvature of this part, it will be here R2, that will be again R, but it will be negative here, okay? It will be negative here, okay? So it is as a consequence of the sign convention rule and all that, okay? So it will be, P will be here 1 over F, it will be mu minus 1, that will be here 2 by R, okay? That will be here 2 by R. P is given as 4, that will be, yes, mu minus 1 into 2 by R, okay? Which implies 2 will be equal to mu minus 1 divided by R. This is an equation that I will use for this piece, okay? It will help me in order to look this problem more correctly and all that. This is something I will put it here as usual for a moment in order to discuss, because I need to calculate, as a question asks me to calculate the focal length of this cut piece of lens, okay? So for that I will again use here the lens maker's formula for this part of lens, okay? But the focal length of this plano convex lens will be, yes, it will be, I will just name it as 1 by F prime, okay? This will be the focal length for this cutted piece, and it will be, yes, again mu minus 1, because the refractive index, it's a property of the material. We are not going to change the material, okay? Material for this cut is same as the material for the lens as a whole. It means that the refractive index will be same here, okay? So for this part it will be 1 by R, okay? For this part it will be minus 1 by infinity, okay? So it will be mu minus 1, okay, because it's a plane part, okay? So its radius of curvature is going to be somewhere at infinity. So it will be mu minus 1 over R, okay, because 1 over infinity is 0. It will be here simply 1 by F prime, okay? Look here, if I just look at this thing, mu minus 1 divided by R, that's given as 2. 1 by F prime, it will be P prime, because 1 over F is defined as the power, okay? So power of this cutting lens, mu minus 1 divided by R, that we calculate here, it's 2D, okay? As I told you before that it was not a big deal to find its answer by using this special formula, but how correctly we need to use it, that was my point of interest, okay? Because there was some unknowns in this question, like this question is, confusing rather than it's simple. By the way, like Many other students will look for as if it's not given ready or not given how we can approach the problem of this type. But we don't need to worry here, because once we know how exactly we can use this equation, we will get here everything at the first place. Okay, so that's why I at the end I'm just getting this answer here. Okay, this is the confirmation that I told you as before. So this was basically all about this problem. Thank you.